Okay, so today is going to be starting the project of actually getting this reconstruction done. And since none of the CADs are fast enough, or they do all this non-manifold, but anyways, I wanted to come on here and actually talk about, because I don't think I've ever done this on stream, of what the vision here actually is, long term. Um, just a bit, I would say the initial question is basically that has always fascinated me. And I was thinking about, I don't really remember my first stream, but I think that this question was a big part of what motivated me. Now, I don't actually remember, and I don't even know if those are public or even if I have them. It was almost certainly sometime in college. Um, Actually, you know what though? It might have been in high school, but it was like video games. In any case, the question is, what do people actually do? What do people do with their time? What do people do with their time when they're working? You know, I feel like there is heaps and heaps of lies in the corporate world of, what were you actually doing? Oh, I was working on this. Uh, can you show me? No. It's like, well, why not? No one thinks. Just record everything you're doing, and then you have proof that you are actually doing what you said you were. And I think it's not just super valuable for keeping people honest, but it's actually of interest to everyone else, not just in the organization, but in the world. Because I feel like humans innately feel that the grass is greener on the other side. They're doing that when people are doing something that they're not, or are living a different life than them, and they just like to imagine that. And making that public of like, oh, this is what people do here, is super, super valuable, because it can inspire someone to really change the course of their life. I don't want to get all high and mighty on that, but I think it's really important. But so the idea then is, if you're making an organization, you should have everybody streaming all the time. Then, so imagine there's 10 people or 100 people in an organization, and they're all working on the high level, the large, here's where we're going with this organization. Um, well, I don't know. Imagine all of these people are streaming and all of it is public, and you can see all the meetings, everything, to an extent. Obviously, this is not possible fully, right? Because there are just like certain things. But I've always thought, how do you just keep what is the company doing as public as possible? Even if you're a privately owned company, keep your balance sheet public. Why not? What are you hiding? You're not hiding anything. Get all that accounting stuff public, just to show, look, this is how this company operates, and this is, imitatable by other people. Um, but the cool thing comes in, okay, so now you have 100 people producing 100 streams a day. Now you want to hire a bunch of people to actually manage those streams to make the content for what people will watch. So it's not only going back through and starting to make stories about the thread and the direction and the arc of individual projects of the company, but it's also literally switching between, like a television person, switching between cameras to be and giving their own narrative on what's happening. Oh yeah, so this person is actually doing something to support this, and they're responding to chat, and they're doing all sorts of things. And this would be valuable not just to people outside the company, but definitely inside the company, because if you don't want to um, maybe interrupt someone or do anything like that, you could just ask the AV guy, who should be very on top of, because they should be extremely knowledgeable about the panopticon of the 100 people streaming, of what is actually going on in the company. Because, if you're working and you got to lock in on something for 10 hours, that should obviously be encouraged, because that's when those real step change leaps happen in the state of any given project. Um, but there become times intermittently where you're like, okay, wait, but now it's time to integrate and time to join and compound. I need to ask someone that's knowledgeable, and maybe you could just visit the stream and ask in chat. Or, anyways, there's many things that could happen. Uh, but so I feel like that's all I really want to say. But that is the dream. That is where I want all of this to go, because there's just something so exciting when the company is basically a series of live streams, and that is, you know, what the company does is you produce these live streams, but you're also making technology, because it's exciting, right? Anyways, that idea just gets me up in the morning, because it's like I've never seen it done. I've never seen anyone owns an organization where everyone is live streaming. Um, oh yeah, wait. We want to add. Okay, so now we'll get back into work. But what I want to add a to do here, because we need to add another render where you have timestamps only on events. Not individual segments. Yeah, I feel like that makes sense. Okay. Oh yeah, and obviously start getting this updated daily or something like that. I don't know how we're gonna do that. But yeah, man. I don't even care if I'm the one to do it. Obviously, I want to be the one to do it, but I would love to see, because like I'm pretty sure like investment firms like Bridgewater, like they back since like the 80s have recorded every meeting. So they have this huge library that they can go back through and see what did people say, how did they make the decision at any given time. Um, but that's only a super small fraction of what actually happens. So, oh yeah, wait, hold on, sorry. You know, do this. Okay. So the goal today is we basically we basically need to learn a bunch of stuff, because I don't actually know how this works. Um, um, but okay, the general thing. Okay, Rust struct for a rectangular cube. Let's see how it just thinks. No, no, no. See, oh wait, but maybe you could do this. Yeah. You could just have a position struct associated with it. I don't know. Let's just make it as dumb as possible. I was thinking just 8 coordinates. Oh, I guess you only need 6 coordinates. That actually is very smart. Okay, and so then the next thing to do is to write the code that takes the G code, parses all that stuff, and then constructs the rectangular cuboids. Okay. So let's just We have print sim, but we can do it in print sim. We haven't worked on this in a while. I forget where this is at. This is a whole mess. Yeah, it's one of these repos where you're just like doing a bunch of nonsense. See, is there even a... So let's just do it in here though. Init dot. Does that work? Okay, so yeah, let's just add this because I'm sure that this is pretty correct. And it's like, okay, so the reason why I even started doing the lean thing of proving whether or not it was a rectangular cuboid is because I had the idea that you need to have 8 points, you know, in Cartesian space, because that is kind of what it is. In any case, yeah, but I wanted to prove it and I wanted to know that they were just in case we get one. But in this case, since we have the G code and we know what the rectangular cuboids need to be, we can just assert that they all are actually rectangular cuboids. So I'm just gonna say cuboids from now on. But okay, what is the cuboid versus rectangular? Oh yeah, it's the whether or not it's trapezoidal or whatever. So all right, we can just delete this. We can just do is cube. Oh, that's just right. Very cool. Check if a point contains. That's great. That's great. These are all functions that are nice to have. Yeah. So now I'm actually surprised there isn't like a very good 3D printer G code parser. But I don't really care. So now, okay. I think I am going to all right, so let's just okay, so then let's just say it's a rectangular cuboid specifically, right? Because whatever. So from G code, and then this is going to take what should this take? A file name or a string? And this goes to vec of cuboid. Okay, so now oh god, I hate this shit. Can you do this? It should type input should work now, right? Error. Wait, can I just do this? I don't even know what anyhow does, but I've just seen before that this thing allows you to just get rid of these stupid errors. So now what we want to do is we're just going to say S is the string of the whole G code. So now what we want to do is we want to say file and we're just going to copy. So the test. So okay, let's do. Is this was not manually okay? Can we open up? Um. Is there? Oh, this is the. Okay, so yeah, could we open that up in? Well, let's open up in Bamboo, and then if it's weird, let's open it up in. Oh yeah, okay, yeah, and then the things to check. Okay, so to do here is in feature script, make two cuboids that share a single edge, and see if union fails. Because I'm pretty sure that this is the. I'm pretty sure this is the def of non-manifold in CAD. So I don't know because well we'll get to that. We'll cross that bridge when we get to it. But okay, let's open that 3MF file. So this is going to be in .rust print sim tests worm drive. This is the step file, but we want this. And so please confirm that the G-codes are safe. Yeah, it's safe. Okay, so this didn't have a brim, but what is that? Oh, that's just okay. So that's interesting that this one didn't have the brim, but the square did. Okay, I need to take a shit. Okay. And the other thing that's so beautiful about is once you start to have everyone stream and you embed it into the DNA of the company, it just becomes certain people's job to capture increasingly more of the process. And so now you have this positive feedback loop because it's just in the company, this is how everything is communicated. It's just we look back at the VODs and we just have this huge database of like everything, and it's just such a virtuous cycle. Why not just start with the warm drive? It's a totally arbitrary decision. So let's just copy the. Does this work? God. I don't know if this works. Does that work? I think this works. Right? What? I gotta get Copilot back. I even have an edu email, bro. Okay. Stuff that piles up. It's so annoying. Oops. Oh, so it runs it from there. Nice. Okay, cool. All right. So the next step is to now copy that logic from Julia. Unfortunately, this thing is a total freaking mess. Okay, so wait. Let's just make an old. Oops, that's not what I wanted to do. And this is all. Oh my gosh. Okay, so we're just gonna take all of this stuff. I don't even care. I'm just gonna dump it over here because I don't know what it is and I can't be bothered. Okay, but we do need to look at, I'm pretty sure it's this, but it's like such a mess, right? I don't think that's it. I think it's this. No, maybe it's this. Does it? I think this function is accurate. Group contiguous paths. Wait, so if we go to worm drive coordinates, is this a oh, it's huge. That's okay. Yeah, but this is nested. No, this is just the coordinates, right? Okay, and then let's just rewrite the code. So I'm pretty sure the logic is just okay, so is there split lines in Rust? Is there an example? That's a space. So I should be able to do just this, right? Can I do this? No. What? There's no len on this thing? What? Can I do that like this? Oh, like this? There we go. That's nice. Okay, so there's a, yeah. And that's just how many lines there is. Okay. So we wanna, okay, so it's gonna be, it's gonna be like, this is that, for, we need to, if L dot starts with, G1, starts with G1 and not L that starts with G1F. I'm pretty sure that's what's up because uh has warmed gcode. It only ever changes the feed rate independently of everything else. Oh, interesting, man. See how it modulates the line width? Ooh, I actually want to. Let's just do some basic statistics on this with Julia. Um, um, so this is just going to be what the hell is going on? Then we just need to filter starts with S like that. That's all we have to do, right? Wait, why didn't it work? Oh, oh, oh. Isn't there a read lines? Dude, that's so sick. Okay, so now we just need to is there a one arg split? No, there's not. We need to do last split space. Oh wait, we could just do this. Last last circ split LW. Okay, oh, and then is there a one arg parse? How do you do this again? Wait. We want to parse that, right? So is there a one arg parse float that? Well, we could just do this. X2 parse. Oops. Sick. One line, dude. I love that. Okay, so now what we want to do is histograms. There's plot, but I thought there was like a really good one that guy made. Okay, whatever. That's cool. I didn't even realize they were doing that. Because that is the computed flow rate thing. So if we just parse that, actually, you know what I want to do? See that? Actually, this is the key, bro. Because what just happened? Did you see that? Ugh, God. Just such crap. Yeah, bruh. I'm pretty sure that this also means these are the. What is the condition? Is the condition that. Wow, yeah, I want to know the min and max too. That is so interesting. I mean, we might as well do that when we make the cuboid. So what we have to okay. By the way, I can't stream for like a long time. It's a school day. Sorry guys, got school. I actually really want to bring my laptop and stream me using the lathe, but I don't know if I could make that work. Actually, in class, you do this sick thing where you had a GoPro attached to that, and you put it on a TV, and Man, I want to do that, bro. I want to show everyone me going hard on a lathe. Um, Dude, I don't know why there isn't a parse float 64, just a one argument version of this. That then you could call this on a, like, let's make that work. So the answer to that is just parse t is equal to x2 parse tx. That's it, bro. That's the whole thing. All right, so whenever I do this, I like to restart. It's a very finicky system. Oh yeah. So just put this up here, and now you can make this actually beautiful. Oh, look at that! See that? Now that's a call. One line that does, dude. If you try to do that in Python, people would laugh at you. They'd be like, I don't understand how you can compose functions so easily." Okay, wow. So look at that. So the minimum line width was, it doesn't go very much below, but it does go up high. So let's get a histogram. That's kind of interesting. So yeah, see how it's like, it's not, I mean, there is some like biased, I'm not a stats guy, so I don't really know. But you can see here that there's a couple of common values. That's pretty cool. So anyways, what we need to do, fam, is first I want to figure out what is the condition that no, see, okay, see, you can't use this as the condition to find all of them, because look at this. It only does it when the line width actually changes. So yeah, we can't do that. Oh, but I so want to add that. Oh, that's so cool. I hate this parsing stuff though. Um, Mainly because I feel like I forgot my notebook. Let me get my notebook so I can start to write some notes down. Oh, I'm so excited by this plot though. I love this thing. Okay. Yeah. Okay, so let's just remember what this gives us. So what we want is um yeah, we're ignoring line width. So we're just getting basically the output of chords.jl. So, or not JL, of JSON. So this just gives us a vec, or a, yeah, a vec of vec. of tuple. I'm pretty sure that's it. I'm pretty sure that's the output that we want. And these are all, and the tuple is, yeah, chord. It's all pseudocode, but basically that's what we want. Okay. Okay. Um, oh, and I guess we'll do this. No F. Oh wait, are the Fs are exclusive, right? Check F exclusive with XYZ. I'm pretty sure that they're exclusive. So if we just open up this, it seems like they always. Okay, so we're just gonna assume. Okay, so assume. Okay, so wait, I'm gonna copy that in here actually. No F. Okay, so then we can comment this out. Then we have to put commas here. Is that right? I guess it is right. Okay. Okay, so we'll call them C's. Let C's equal S dot split space. Okay, in this example, G1 X1 Y2 Z3 E.5. Okay. And so all this is going to do is give us what we want. So oh, and isn't there just a dot skip one for C and C's? If C dot starts with, is there a way to match it actually better? Oh, can we make a default where it's zeros? Whatever, we'll just say let. Can I do this? Can I do that? To match on a tuple. What if I just do this? Um, okay. Okay, so yeah, let's just write it by hand. Who cares? Um, is there a way to index? Okay, wait. How do you? Okay, I'll just ask this. What the hell is going on? Um. Oh, I do collect. Wait, no, 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 no. Why? It's always going to be at the start, so I just need to skip one. I don't need to do a filter because that's O of n. I just, but I do, and I also want to parse it to a float. Okay. Wow, that's great. Okay, there we go. It's always going to be, right because it was generated by a program. So, yeah, this okay. But we can just do else copy Okay. X. So now we just need to do this. Y, Z, E, Y, Z, E, K. How do you do this again? I don't even know how you do this. Wait, is it like, how do I actually construct one of these given that I have X, Y, Z, and E that are all options of float? Oh my God, you're being so annoying right now. Oh yeah, okay, so that's how you do it. So you just, I thought there was a way to do it where it is even better. Let's ask it. Isn't there a way to make this to make the constructor even shorter if the like field name and the value name are the same. That's nice. I like that. Time got out tonight. Okay, so I think I just have to do this, right? All right, so we'll just do 2 passes. So let mute vec g1s equals vec. Let g1s dot push g1. Oops. Wow, that's a lot of G1s. Okay. But so now for each one of these, we need to keep track of the current position, and then we need to I guess we need to do this, but then we need to do this. Okay, then let mute cur extrude equal to 0. And oh, it really doesn't promote like that? Okay. I can't believe I'm doing this again. This thing is so annoying. I don't know why I don't like this so much. Let's go back to the square test. It's still so much G code. Okay. Oh, see here? I forgot about that. You can still filter out those. Okay, yeah, you can still filter out those, but it's like kind of pointless. Like, so this is that's the first G1, right? No, this is the G1. Okay, so you set your position to 5. What other features are there? Interesting. No, this is a base 64 encoded thing. That's cool. I remember. Oh, it's so funny. It's like I'm in this I'm in this CNC class, and I was putting semicolons at the beginning for comments, and he kept deleting them and changing them to parentheses. It's like I don't know. He didn't even know. It's all good, but um. So what do we need to do here? We need to um. Okay, bro, why am I being so dumb? So the logic is we're gonna push to the coordinates if the e in here. So if g dot e first of all is sum and okay wait. Can I do an and here? Can you do that? Okay. So we'll just do this. If e cur x plus e greater than 0, then we're gonna take um, does it, I wonder if it ever extrudes where it's not doing a move. I feel like there's no way. Oh, actually, I could see it. Uh, then do I do that? Is that how you do it? I don't know how you do it. I'm pretty sure you do it. Oh, right. So, oh, we could do this. Does it have to be the first argument? I don't know how that works. Should we just keep? No, we don't want to keep it as G1s, but we also don't want to make a structure because then once you have a bunch of structures, it's just all fucking annoying. And this is going to be a G1. And this is going to be a vec of 64. Okay, so what we want to say is if let sum x equal to cur x. Okay, wait. I feel like this might be able to get it. Yeah, there you go. Unwrap or. There we go. I think we can just do this, right? And then we want to say cur x equals 0. Is that the only thing? Oh. Let's say there's two minuses plus equals e. I'm pretty sure that's correct. Oh, but we're on. Wait, this is definitely wrong, right? Because we need to update the. Yeah, that's definitely wrong. I don't know why I have such a hard time like being the G code. I should just feel the vibe, bro. Gosh darn. It would be cool to do like a formal, like to do proofs on G code. Um, so wait, so no matter what, we kind of want to do this, right? Okay, now we need to write that to JSON. Okay. Wait, vec of chord? I don't want that. Pretty sure I can just. All right, let's let's put this up here. Did it do it? I don't know how to validate that these are correct. Well, let's do it with the let's do it with the 254. That sounds about right, actually. Let's why can't I scroll down? Did anyone ever respond to me? Cool. Should we try that? That'd be good. Delete faces. But how do I know which ones to delete? In any case, let's just get this show on the road. So we're going to do a new part studio. We are going to go to import, right? And we need it to be the JSON. So we need to go to .rust print sim square coordinates. And then let's look at this sweep chords thing. Okay. And all we need to do is import files. What the hell's going on here? Import. Holy crap. How long is this going to take? Literally, what is going on? We're just gonna make a. Can we just make a new Feature Studio? Oh my god. What? Wait. What? Oh, you know what? You have to save it. I always forget that. Yeah, that looks right. Okay, cool. So we did it. Okay, so now we just need to actually make the cuboids. So now, wait, let's commit this stuff. Okay, so move old stuff and parse G1s to chords.json in Rust. Also line width stats analysis in Julia. All right. Bang on, bang, bang, bang. All right. Okay, so so this is sort of the new part now, is like, okay, so I think the first step to do is to just come up with the 8 coordinates of the so it's not going to be cuboids from gcode, it's going to be cuboid from seg, and this is going to be a seg is a line segment, which is a vec of It's a vector of f64. So let a be equals seg 0, seg 1. Okay. So now you're going to take A. Oh, and you need to do a little bit of trig, huh? You don't actually need to construct a plane or anything, but you do need to make sure that you, because you can't just subtract directly from any of the XYZ coordinates. You need to if you're drawing a triangle, it's like this. You need to know 0.2 out this way decomposes how. We can do this in TL draw. Is this just let me, okay, so let's say that we have, bro, just fucking, what? I thought there was just a how do I draw? Oh, okay, so let's say you have A and B, so you're like this. This is A. I need my mouse, but whatever. B. You need to go this way by 0.2. But this is Y, and this is X. So now what you need to find out is to draw this triangle is this angle. So you know that this is a right angle because we want it to be. We want it to be a right angle. So yes, what we want to do is we want to make a down here. And then this angle is going to be the sine. So this is going to be sine of wait. AB or B, let's say B minus A. Fuck, this is impossible. B minus, oh Jesus. Sine. Wait, let me just check my trig knowledge. So if we have a triangle like this and this is 45, so this is going to be root 2 and this is going to be 1. So what we're trying to figure out is this angle. So if we do opposite over hypotenuse, so sine 1 over square root 2. But that's in radians. Can we? I'm pretty sure that I need to use inverse sine, right? God, just goes to show how stupid I am at math. Yeah, so that is wrong. So wait, we need to do. Okay, so we need to just take the inverse sine of that inverse sine of B minus A over, and it's going to be, so to find this coordinate though, it's going to be using the y component of A and the x component of B. And we assume that A and B are on the same Z, which I don't know. Pretty sure is correct, but I don't know. Okay, so let's just do it. So what we want is why does this not work? What? Okay, let's just say, okay, we have B minus A. Let hypotenuse equal B minus A. That's not, it doesn't work because cannot subtract vec from vec, which honestly is a semi-reasonable design decision for a language like Rust. And then what we want is let op broma ops. So it's going to be vec of, so the x component is going to be b dot x, then a dot y, then a dot z. Assert a dot z is equal to b dot z. Can you just do this? Okay, yeah, fine. All right, let's just do the thing like this. Oh, yeah. This is going to be 0, 1, 2, 2, 2. Okay. So the hype is going to be, let's just do this. Vec b dot x minus a dot x, comma, and then we're just going to do this, copy, copy, and then we're going to do this, y, z. Oh, shit. Screw it. Okay, so now, hmm. a sine wait, arc sine is the same as inverse sine, right? Okay. So all we need to do is we just need to do op over hype dot a sine. Let angle equal this. But they're vex. So we need to take the distances, I guess. So wait, first let's just do this, and then we can get rid of this and this. And then what we want to do is oh, you for real? Is that true? I honestly don't know if it's right, but we'll figure it out. So now what we want to do is we want to draw that other triangle. Where's my teal draw? So now we know this angle because it's going to be 180 minus 90 minus 80. Okay, wait. 180 minus 90 minus angle. Okay, so what angle 2 equal 180 minus 90 minus angle? And we need to make sure that we handle the case that it's actually that in the event that they're on the same axis, that the zero. I think it should be okay. No, it might not be okay. No, because sine 0 is 1, or cos 0 is 1. So in the event that the angle is 0, then it'll be straight up and it'll be all good. Okay, so um so the hypotenuse, and we're gonna need to compute it this way too. But that should be easy. Because all we need to do is find this component and this component. So what? Now that's weird. You can't just write 0.2. It's kind of crazy, man. So now we just need to do let y or x component equal to hype2 dot cos times wait, this is the length. No. So this needs to be angle 2 dot cos times hype 2. Cool. Okay, so now we just need to say that this corner is going to be at A0 plus, so this is the x component plus x component, A1 plus y component. And then the other is going to be this, and we just swap this, right? So in a sense, I don't know if this is actually what you're going to call it, but this is going to be, for me, like the top left, top right, and then I guess we're just going to do, so let's put these in here. So this is going to be A2, and then be bot, and this is going to be minus 0.2, or wait, let's just do like a const f64, or wait, const layer height type f64 is equal to 0.2. Let's just do that. Okay, and now we need to add B, and then we have our rectangle to both of these. Ay, bro. We're almost there. I want to get my mouse. I want to do the little test to see that if I have two cuboids that share a single edge, if the union fails in feature script or in Onshape. I'm pretty sure it will. I'm pretty sure that's the definition of non-manifold. Let's see. Do we have any views, bro? 8 views? Man. It's because it's cool enough. Because the thing is, it'll be cool when we do the union. I don't even know, because that's something totally new to me. I don't even know how you do that. I do like this trig though. I mean, this is real Greek shit, you know. Spina capita, you know, real. Dude, I could go for some of that right now. I love those spinach pies. Okay. Yeah. So, we have cuboid. So the thing is, okay, we'll need to like figure that out because right now this is not actually whatever. So we got the top left, the top right. Uh, we'll call it back, I guess. So actually, all of this is going to be front. So now we can just copy this and turn this to back. Wait, oops. Back. And then, so this is going to be actually, we could just do B0, B0, or B1. And we should, well, we did the assertion, so it doesn't actually matter. So now, okay, so all of this A stuff, we can just make that B. Cool. So these are the coordinates. Let cuboid chords equal vec. Go all the way down here. Close it off. Take all these semicolons. Oh, wait. Turn them into commas. I'm just going to ask it. Do you see anything wrong with the code here? Wait, what? Wait, height 2 should be layer height. Do we even use this? Oh yeah, it's right. It's not the layer height. It's the it's half the line width. Wait, but I think okay. So there's like a bunch of problems then. Okay, so yeah, so right, that's definitely wrong. Is there a degree Rust degree cos or sine? Okay, so we could what were the other issues? Oh, it is a tan too. What? I, I actually don't understand what's wrong with my... I don't actually understand what's wrong with this angle. How is this wrong? How is the angle wrong? Wait, but this sounds like what we want. Actually, yeah. Okay, I gotta think about it. Okay. All right. That's fine. So this is right. Okay, so wait. So it's not necessarily, it's not actually guaranteed that, even though in the comments I say like front, top, left, it's not actually guaranteed that those are going to be like the minimum or the maximum. So when creating the cuboid, you actually need to do the max and min to make sure that the points that are actually the mins are actually the mins. Chords is used, yeah. So okay, wait, a pair of two coordinates is called a segment, and we can just do this. Cuboid from seg, and then cuboid from chords. So we got the chords. So now we just want to call cuboid from chords, cuboid chords, right? Pretty sure I just need to put the OK here, right? Wait, why am I getting a vec of cuboid? Okay, so let's test it out. So we're going to take the first one of these chords. Let cuboid equal cuboid from segment chords 0. What? Oh. Nice. That's fun, man. What is the unit of that volume? It should be in millimeters cubed, cubic millimeters. Wait, actually, that would be a good way to test whether or not this thing is right. Is we take up the sum of all the volume. Well, no. I mean, it'll be off, but it could maybe, like, okay, when we slice this plate, it says total filament. What is the density of their PLA? Is that a setting? Wait, why? Oh, wait, why doesn't it? Total filament M? What is M? I wish there was a tab. I wish there was tabs so I could keep this thing open. I think that you can just by making a new plate. So we want to go to 3D ball shooter unshape worm drive. Okay. So this one, oh, what the heck? Why doesn't it say the grams of filament used? Let's just restart it. I feel like it's because of this weird MF, 3MF settings. Add 10 grams. Okay, so let's just say bamboo PLA density. Okay. Okay. So what we want to do is now I want to do a map. I don't like the, so okay, so we're going to do chords.map, wait, iter.map, and then we can do what? X to cuboid from seg X dot collect. Oh, and then you have to do this vec of cuboid or something, or I think you can do this, right? Map. Oh, because this doesn't accept a reference. I think it could just take a, I think it doesn't actually need, let's see, what happens if I just add this? Oh, wait, okay, now what we want to do is sum up the volume. It's interesting they don't give you a volume calculation, actually. Okay, so now we want to do C's.iter.map x to x.volume dot sum. Let vol equal, oh yeah. What? Huh? Wait. What is the type of this now? How does that not satisfy sum? Is it some stupid NaN thing? I don't even know. Wait, let's just iterator with item equal f64. How to sum. This gives some totally dumb error. Oh, really? That's what you have to do? Okay. It's kind of weird, actually. Print line volume of print assuming 0.4 by 2 by length boxes. So this is the volume in, convert this millimeters cubed into grams using So that's totally wrong. Grams per centimeter cubed? Wait, first off, wait, hold on. Maybe this is in centimeters cubed then? I mean, all of the coordinates are in... Wait, let's go look at the volume code. I mean, it's definitely millimeters, but it's like... So something is super wrong then. Arg. Gosh damn. Wait, can we just print out the length of it? Oh, wait, okay. Silly old me. It's because we switched the file. Even still, that's definitely... Wait. Wasn't this just... Oh, this still seems kind of wrong. Okay, let's switch to the worm and just see if it's super slow. Is it that? It's probably going to take forever. Oh, it didn't take forever. $36 cubic centimeters. So it's actually overestimating, maybe? It's saying it takes 10 grams. Wait, can we just compute a volume based on this distance? Because this is the meters of it, and the diameter of is 1.7 millimeters. So don't we just need oh wait, this is going to be times This is a diameter. So we need it to be an area. Millimeters times, it's the area is pi r squared. So pi squared. So we're gonna do 60 cubic centimeters. So it's actually saying, but then how is it getting 10 grams? That's what I don't understand. Wait, did we get the calculation for the diameter? The diameter is 1.75. So we got that right. So then this is saying that it's 60 cubic centimeters, but we're saying that it's 36 cubic centimeters. But then we're also saying that for every centimeter cubed, so we have 36 centimeters cubed, that we have a, so it should be, oops. Wait, hold on. Let me just stop being an idiot. So it's 36 centimeters cubed times 1 gram over 1.24 centimeters cubed. So it's actually going to be, so it's going to be 36. What the hell is going on? 30, I'm just dumb. 36 over 1.24, 29. So we're overestimating the volume. We're overestimating the mass of, we're overestimating the mass of used, but underestimating the volume. Well, if my calculations are correct. But I don't see why this would be wrong, because this meter calculation is definitely meters of filament. I feel like this just doesn't line up. How can you use 3? Okay, let me just double check with GPT. Okay, use Python to verify if I use 3.5 meters of PLA filament that has a 1.75 millimeter diameter, how much volume is used? Oh, you know what? Oh, wait, I did pi d. Wait, what did I do? I definitely did something wrong. Wait, pi r squared. Yeah, I did something definitely wrong. So, but then this is the volume. So it's going to be 8.4 millimeters cubed over 1.24. 6 grams. So even this underestimates how much. So I wonder what they're doing. But anyways, wait. So we need to go back to wait, is the volume? No, this volume is fine. It's the, but at least it's somewhat close. At least we're not being total dumbasses. Wait, actually, wait, hold on. Oh, no, 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 no. It's going to be 8.4 times. Okay. All right. So we're good. This is exactly what they're doing. It's the perfect calculation. So
All right, at least I'm not tweaking, and that's how they're calculating it. Is they're just doing a basic volume density thing. Okay, so then why am I so greatly overestimating the volume used? Should we look at the Bamboo Studio? Is the slicer even in that code? I don't know. Okay. Let's commit the code which is cuboid constructed volume
total volume calculation seems off, quite off. So yeah, so it's interesting. Let me get my. Oh. Okay, so yeah, so we committed the code. Now it's wrong, certainly, but I wonder how much the line width. Okay, wait, let's look at some G code. So we go to tests, worm drive. G code. So you see here, look how little. It's barely extruding anything. I mean, I'm thinking this is in millimeters, but that can't be right. Let's look at the Marlin firmware. What is the unit of measurement? Yeah, but also that doesn't check out because like, well, let's see. If we take G code E unit of measure. God, I hate Reddit. All my homies hate Reddit. I'll never stop hating Reddit. Worst website. Written in Python. Absolute garbage. Waste. Who's running Reddit? Let's just look up. written in Python, dude. It's literally garbage. 9th most? That's kind of amazing. Who the hell is still using Reddit? Snoop Dogg, bro? That's crazy, man. That's so weird, though. I would hope that it's okay. Can we actually just do some basic statistics then on that? So of all of these, okay, so we want to now do some basic calculation of. So we need to rewrite this thing in Julia. I'd like to have versions in both of them. Hopefully they're consistent, but maybe I'll just do it in Rust because we already have it. So basically what we want to do is we want to take I think so in here. Nice. This is just in main. So let x equal vec this. And then what we want to do is we just want to push so now nah, that's crazy. That bothers me so much. I think all I have to do is this, right? Okay. Oh, sick. 3.46 meters. Oh, hell yeah. Okay. All right. All right. All right. That's right. We just did something correctly for once. Y'all see that, chat? Y'all see that? Dude, still at 8 views, bro. I gotta stop caring. Because once it gets cool, it'll get cool. I think it's mainly that maybe my title is just stupid. Okay, let's go to my. Let's just see, what does it look like when I actually, union of rectangular cuboids in Rust. Eh. Okay, it says that there's someone watching, but I kind of don't believe it. Okay, so this is awesome though. So if we just take this, I mean, we're gonna get the same calculation. So presumably the error is actually all attributable to the. Okay, so extrusion distance is correct. Wait, can we just write that to JSON? So x dot
So we're going to put X, and we're going to say this is worm drive extrusion distances. Okay, and so this does show that it is actually in millimeters. Okay, so now we just want to now that's cool. So most of these, I mean, I guess this corresponds pretty similarly to the distribution of distances. So actually, let's get the coordinates too. Let's just call this, and it's gonna be. Okay, so now, um, isn't there a? But I don't want to add this. L1 distance. I think I want L2 distance, right? That's what I want. Wait, does norm compute the? Oh, oh yeah, okay. Right, that's what I wanted. That's what I thought. Or do I have to provide? Oh yeah. So that's the distance in millimeters, right? See, that's so much bigger. But that's the total travel of extrude. Okay, wait, fine. So, so it's quite similar. I mean, it's pretty much identical. So that's cool, but it is weird that the sum of that is so. Why don't I get a doc string? Is it because probably is something like this? I don't know. Okay, let's just do the thing here. We should be able to do this without no, so that doesn't error when they share a. I thought that errors. Whoa. I can't even understand what he's looking at. An edge can only have two faces. Wait. Okay, so I'm failing to see what is actually causing the problem. That's fine. Can we just do this? Yeah, okay, so that's correct. So that means that this distance thing is right, but it's saying that we traveled 113 meters. But only extruded. Something is wrong here. But I don't know if you, let's see, how did we compute these? No, I mean, this code is, wait, no, it could have traveled that much, but it doesn't, because it doesn't extrude nearly that much. Right, like a third of a millimeter, or no, not a third, a 30th, like whatever, like a very small amount is actually extruded. In any case, we now should probably get started on the real challenge of this whole project, which is this is the line width thing. I do find it a little bit surprising that we're overestimating volume by so much. Because what did we say the volume was? 36 cubic centimeters. Oh, 45 grams. So off. We're off so much. I don't know why. It must just be that I'm building too big of a box. I mean, that's fine. Is there any way to better estimate the... Because the layer height is correct. It must just be the... Or, I mean, you can see in the G-code that the Z values that it does is always a multiple of the layer height. So I feel like picking 0.2 for that height is... Or using the layer height as the box's height makes sense. I mean, it must be. I mean, if you look at it, the slot is not really... Like, what we could do is we could make a... we could do, like, L... L... wait, what the hell? Okay, then these equal here to here. Oh, wait. This to this. Yeah, it's that outer. This needs to be So we could do that. Because the volume of this is going to be, let's see, if we draw, oh wait, why is this? Okay, so it's all locked in place now. This is the sketch. So let's compute the volume of this. So it's going to be one circle plus, and then let's just draw some construction lines. And just get a dimension here. So that's 0.2. So it's going to be 0.2 squared plus one of these circles, which is, wait, can't we just get the area of this by clicking on it actually? So that compared to, so that's like, yeah, that's less. Okay, well, yeah, so wait, so if we just do 0.2 times 0.8, oh no, it's like, yeah. Wait, 0.2 times 0.4, what the hell? Yeah, okay. So this compared to 0.0, so if we do, dude, why does it just like never, okay. Yeah, so it's like 0.88, 0.9, so it's like a 10% decrease. That still doesn't really make sense though, because we're overestimating by 4 times. Is my math wrong? Can we look at the code for me defining the cuboids? In any case, I feel like we should just move on. It would be cool. Maybe I don't know. I feel like I'm just procrastinating, but I do want the volume calculation to be kind of right though. Because if we get that right, then we're guaranteed to be a lot closer in terms of the geometry. I mean, you really want that quantity of the volume of the sum of the box, the total volume to be equal to what Bamboo says the volume of plastic extruded actually is. So on the other hand, the real challenging part of this project is definitely figuring out how to union all these things together, especially in a fast way. Um, I kind of would like to. Okay, so the first thing is you take the. Okay, so let's add move this to the top here, and then this is going to be uh, uh, anyways, what we want is what am I trying to say here? I just lost my train of thought. What I'm want to do is take. Oh yeah. Okay, so let's just do a. So this is going to be okay. So the distance. So then it's going to be 1.7, or it's going to be fill over 2. Is there like a no, we don't want that. Okay. Is this over 2.0 times pi. How could you be so heartless? Uh, yes, it's pi r squared. So this is the area. Oh wait. Can we calculate in this? So this is gonna be. Hmm. Really? No. Isn't lazy static? I mean, it still works, but the last release was 4 years ago. All right, I don't care. Premature optimization. Does anyone really care? So this is going to be this times x. So we want to now calculate the line width. Okay, so then the volume. So this is the volume of plastic extruded over the entire path. So we have the box. We want to now calculate the line width. That's the only distance that we get to actually play with. I feel like it's gonna make gaps if we do this. In any case, I still want to do it. But basically, so now we need to you just need to do the algebra to solve for the actual line width. So we're given this. So okay, so we're given so let's just say that we have a seg disk type F64, and then we have vol of type F64, and we want to get an F64 out of this. So so it's going to be 0.4 times 0.4 times 0.2 times. Oh wait, okay, so yeah, so it's 0.2 times seg dist times x is equal to vol. Oh wait, we'll do. Okay, cool. So now we want to iterate through all of the. So first off, we probably want to. Well, we could just. It's fine. We'll take all the chord pairs and we'll take all the x, and they should be the same thing, same length. So we can zip it all together. And then compute. I feel like I'll just do this in Julia for a second. So are they the same length? Okay, sick. Oh wait. Dists and x, right? Dists and j. So what we want to do is, first off, but it's not that. It's Oh wait, let's just make sure that this is not being weird. Yeah, because it was different, right? Because yeah. The precedence of the parser put 2 pi together, but that's not right. Okay, so this is the area, so the volume is now times E. Wait, why is it? So what is that area? That area is millimeters squared. Let's just double check that. If I have a circle with diameter 1.75 millimeters, what is the area? Please, it's got to be the. Oh wait, here it is. 2.4. So we're right. It was right there. All right, cool. So it is right. Now we just need to take these areas and map this. So f of dx is equal to, or volume is equal to volume divided by 0.2 times d. So now we just need to calculate the volumes. So vols is equal to this dot times j. Wait, no, wait. Areas. Now we want to map x to f of so this is going to be, these are the widths. Whoa, no way. That seems suspicious. That seems suspicious. Because I was expecting it to be a lot lower. Wait a minute. Wait, so this is a quantity representing, so this is going to be millimeters squared times millimeters. So these vols seem off. Oh yeah, so this is not right. So we need to actually change this to be. Okay. So that actually checks out way more. I mean, it says the line widths are all over the place, but if you were to actually normalize by the distance traveled, it's okay. So why don't we just so what we're gonna do is we're gonna modify our code. The thing is, I still am a little bit suspicious because even if we change, so let's get line width here, and we're going to change. We're gonna find the 0.2. I'm gonna change this to be line width over 2.0. Okay, and now we're going to change this to be 0.35. And then we're going to rerun everything. It's barely decreased, right? I mean, it's still saying that we have printed so much. Let's see if there's any more occurrences of... Hmm. I mean, because, yeah, you would have to make it... Like, if we were to just solve for what it actually is... Wait. Okay, so something is definitely wrong, right? Because... the volume should be decreasing faster than that. Okay, so I think I found the bug. Because that's just impossible. I mean, I don't think that there's a problem with the volume calculation itself, but if you got a 0.2 by 0.1, I just don't see how... Oh, you know what, though? No, I don't know. Because this is in millimeters, right? We're working in millimeters. So even if we made this 0.01, is it... Yeah, I mean... I'm very suspicious here. Also sort of found that decreasing line width to 0, the total volume doesn't really go below 30. What is this? This is going to be 30 centimeters, which is still about 3x too high to match the predicted mass of extruded plastic. Okay. We'll get there. Okay, I think it's time for breakfast. See how long I've been streaming. 3 hours? Yeah. Okay, time for breakfast. I'm kind of annoyed, man. We got to look through the math. That's the only answer here. Is there's something about how I'm doing the box creation that's wrong. First off, don't we need to make this an absolute value? I mean, it shouldn't matter if we're doing equal. What is going on here? Okay, what happens if I literally just make it 0? It should be 0, right? There should just be a whole bunch of errors, right? Now that is okay. So things should go wrong if line width equals 0, but they don't. Okay. So I feel like we found the problem. So it must be in how we're doing the constructor then. Cuz like this should fail, but it doesn't. Min must be less than or equal to wait. No, it needs to have non-zero volume. You can't have a cuboid that's degenerate like that. But no. Oh, but you know what, actually? No, that's fine. Um, okay, once I eat, I'll feel better about this thing. Okay. All right. So I mean that is a bug fix, but it's not actually solving our problem because the volume calculation is still so wrong. Wait, is that taking the? Wait. No, that's I'm trying to figure out if that's wrong or right. I can't tell. If you have a max and a min in space, let's say that let's just say a square, we're doing 2D just to make it easier on ourselves. It's like this, and you have A and B like this. Okay, so we need to do it. Yeah, we need to do an example on paper. Let me eat and then, so let's chill for a bit and then we'll. Hey, I'm recommending myself. That's a good sign. I like that you hover over it. It gives you an actual preview of what I'm doing. Wow. Holy shit. Yeah, I love those cycloidal gearboxes. Those things are so cool. That's so awesome, man. Oh my god. I bet he has no other videos. That's so cool. I've actually wanted to watch this.
The most common question I get about 3 Blue 1 Brown is, what do I use to animate the videos? And the short answer is that I wrote a custom Python library. Its name is Manum, so it's all programmatic and it's also very bespoke. And what I wanted to do with this video is offer kind of a behind the scenes to show you, one, what Manum is for those who don't know, and even for those who do know, to show a little bit about how I use it and what the workflow is. Now, the way I'm doing this is I sat down with Ben Sparks when I was in the UK a couple months ago. Many of you may recognize him from his many great number file videos. He wanted to know how Manum worked. I knew a number of other people had that same question. So I recorded the conversation. It's kind of a scrappy recording, but we'll make do. And after a simple hello world example, we animate the famous Lorenz attractor, which is very important in the foundations of chaos. It's also just a fun visual to get into. One quick thing I should mention before we dive in is that there are actually 2 versions of Manum. So the first has a history very intertwined with the history of the channel. The way I started the project, basically when I was finishing my undergrad, was that I wanted this coding project that would somehow let me illustrate mathematical functions better as transformations. Made a super scrappy bit of Python code for that, used it to make the first video on this channel. As I made more videos, the tool improved. As the tool improved, I would make more videos. And that's just continued ever since. Like the most recent video I made, which was about holograms. If I do say so myself, I was pretty proud of the visuals in that. And that would have been dramatically harder to do even 2 or 3 years ago. But over the last month, it was actually kind of a joy to make just because of a lot of the workflow improvements over the years. I've always posted all of the code that I make for videos. It's openly visible on GitHub. And I also made the tool itself, the underlying tool Manum, open source. But I don't, as a personality type, really have the constitution to manage an open source project. I also don't really have the capacity for it while I'm making videos. So I wasn't the most attentive to issues and pull requests and things like that. But a community of people who wanted it to be a more robust tool for others forked the repo and created a version that is attentive to issues and pull requests and has better testing and better documentation. And it's called the Manum community version. So it's generally recommended people start with that. But in the meantime, I often do make a bunch of changes or developments to my own. Over the last couple of years, I've made it more interactive, more performant, things like that. The reason I bring this up is that what I'll be demoing with Ben is my own version, but you should be aware that there is this divide and that if you want the better documented and tested version, it's recommended to go with the community one for that. Without further ado, let's dive into the Hello World example. It's all in Python.
Okay, and on the left is a Python, just a text file essentially with...
Yeah, so it's Sublime text. I use Sublime, that's a text editor. We're going to be typing some Python here. I guess just as like a basic sense of what it even looks like to have something up on the screen. Let me get something there and then we can talk through what's going on. Here, I've created a scene. So all of the scenes that I edit together take the form of a class in Python. And then inside a certain method of that called construct, this is where all the code that renders stuff is going to live. There's objects added like a circle. Like, you know, we can add like a square in there too. We're also going to add that square. If I kind of run all of that, we have the square.
How did you just run that? Was there...
Oh, yeah, okay. So this is what...
I think you just wave the magic wand and it happened, right? But you have a shortcut, it looks like.
Okay, so in principle, if over in this little terminal, it's a Python terminal, such that we can call commands on the scene that are relevant. So I might say square.shift to the right, and then that square will shift to the right. And if I call it again, more things will happen.
Okay.
I could also say, what's 1 plus 2? Just normal Python.
Okay, it's a Python just entry box, basically, yeah. But it's talking to this.
And so while I'm creating a scene, it's nice to have a Python terminal that's talking to the scene itself. And then separately, so what might be nice as a workflow is to say, hey, I've got all this stuff that I'm going to do. Like maybe I want to take square and I'm going to put it to the top edge, right? And so a common thing that you might do is say, take that, copy that, go over to this, paste that, press enter, right?
And that immediately tests that line.
Exactly, so then it tests that line. But I don't want to do that every time. I don't want to like do it and copy and paste. So instead I have a shortcut written, and this is tied to some Sublime specific things. In my case, it's Command R is I think the keyboard shortcut I have. It'll copy it and it'll run whatever the text that was copied in there.
So you've got a shortcut which runs this code.
Yeah.
Outputs the visual.
Yeah.
Immediate check.
I just want to jump in with a quick comment here because there's slightly more going on under the hood. Like all things, this is best motivated with an example. So if I pull up a scene from the most recent video on holograms, these can get quite long. So here, this is, the final output was a 4.5-minute MP4 file describing the fraction gradings, and in particular, this one was about the double slit. It's really nice to have these long scenes because they share a bunch of context, and as you're coding, you can kind of reference that context. But the code for something like that ends up being just a big pile of Python, lots and lots of code. And it used to be the case I would break this all down into little subroutines, but historically it's proven to be nicest just to have it kind of all in one spot where all your local variables are shared. The thing I want to highlight is that if I'm working on the scene and I'm somewhere in the middle of it, so lots and lots of code has taken place, but we're in the middle at this point. While I'm iterating writing on just one little section. Like here, I might want to be able to run the code of this section and see what it does. As you can imagine, you might want to tweak it, you might want to change it a little bit. So in this case, let's see what's going on. We've got some graphs being drawn. This like wave kind of showing the red and blue wave is fading out a little bit. So maybe I could say, what if I don't want it to fade out as much? I want that to only be 0.8. I want the runtime here to be a little different. I want to be able to run that same section, but in order for that to work, when I'm pasting it in, it can't just literally be pasting the code. It has to revert to the state that the scene had at the start. So it's really running this little thing called checkpoint paste, which basically says if the thing that was copied starts with a certain comment, I'm going to see if I've seen that comment before and cached a state of the scene associated with that so that I can run it. Basically, it's making it behave a little bit more like a notebook, like a Jupyter notebook. Some viewers might be wondering why I don't just have it all in a Jupyter notebook, but I really like having the scene in a single text file and being able to interact with it through scripts and things like that. But this is kind of like a hybridization between just the raw text file and a notebook itself.
We could also have some text on there that maybe literally says hello world.
Sounds like a good plan for Hello World. Okay.
Yeah, put that to the top. And that's also something, it's not going to show up on this if we don't have this line.
So the adding makes it appear. But and it looks like, so this is me naively thinking, when you make an object, it puts it in the middle, and then unless you then do some two edges or some other movements, it moves it around.
Most objects default to being in the center.
Okay.
Instead of adding it, a different thing you could do, anytime you're going to do an
Dude,
animation,
Grant looks
there's
kind
something
of
called play,
jacked,
and
man.
instead of
What the
throwing in an
fuck?
object, I'll say there's something I want to do to that object. So in this case, maybe I want to write it.
This is the standard progression, bro. You become like you're like a dweeb for a few years, and then when you get big, you're like, you know what? I should start working out again. And you get huge. Okay. So I think that's enough of that. Now let's just figure out why this is okay, I gotta get a notebook. Okay, so okay, let's say we have point A and point B. Let's just say this one's at 0, 0, and this one's at 1, 1. And we have a width of 0.5. So then this is going to be like this, this. Or I guess a line width of 1. So line width equals 1. So okay, so what we'd have right now is okay, so in the case where we have in the case where we have A equals 0, 0, we're doing it. We're just doing it in 2 dimensions, but the math is the same here. So then the angle is 45. And okay, so the top left we need to calculate is so this is also 45. So it's so wait, sine. Oh wait, is that what's happening? No. There's a sign D, right? This is so so we want okay. Okay, so these are equal, but that of course makes sense. So so this is top. We don't want to say top. We want to say okay, and then okay, so these are the four corners. So now we want to compute the area of this thing. So we have 4 points in two-dimensional Euclidean space. Front left should be 0.35, 0.35, and then minus point, and yeah, okay, so this is all good. So wait, back left should be, yeah, okay, so this is all, wait, yeah, this is all working out. So the algorithm for calculating the, well, first off, what's the algorithm for doing this? Okay, so and then what do we do? Oh wait, sorry. Ugh. So so you iterate the coordinates. Oh yeah, start with the first one. Oh my gosh. Okay. Yeah, we can just do min. Oh. Oh, shit. God damn it. Okay, so wait, so what's maxi? What's mini? Okay, so wait, see, that's kind of interesting, right? Because that's just wrong. That's just obviously wrong because now it's picking. Wait, hold on. Wait, hold on. This is wrong. Because these points are now this and this. And then it draws a big old rectangle around this. Yeah, so this is totally wrong. Okay. I'm glad we went through that because yeah. So there's two problems that I guess I found. One is that I don't think you can just well, the one problem is just this is not how you do it. Because that doesn't actually tell you the diagonal. We could just arbitrarily pick, I think, top, front, left, and bot, back, right. I think we could just make that the diagonal. But the other problem is that we're calculating these coordinates incorrectly because if A is at 0, then this point, front left, needs to be at front left is supposed to be should be minus 0.35, 0.35. But I don't know if I can just invert the I think I can, right? I'm pretty sure I can. It's funny how tangled and twisted around you get when you when you're doing just basic 2 and 3 dimensional geometry. It's like it's so easy to just get lost. So would there be a problem if well, the thing is it asserts this thing, but why does it have to be that way? Why can't we just abstract it to a single any diagonal? Unfortunately though, oh, okay, so yeah. So even if you have that diagonal, you're throwing away just by storing the diagonal is not enough. You need an orientation. Okay. Yeah, you need an orientation, otherwise it's going to be oversized. Because let's say I don't have a mouse. Where's my TL draw? Okay, so yeah, so let's say in this case, it's going to draw, let's say it picks these 2 points. Or wait. No, see, it's going to go like this. It's going to make something here and here. So it's now going to draw this where these two are coincident and this is coincident. So this is way bigger than what our original thing was. So we're going to need to figure out how to fix that. Because I really want to make sure that the volume computed of all these boxes is correct. And then we can move on to the next step. Okay. So let's think about it. Let's say we are given this diagonal. The problem is then our dx is going to be like this. So this is actually going to be the diagonal because we don't have an orientation associated with it. So that's no good because that's definitely... Is it the same? I don't know if it's the same. Okay, so if we have... All right, in our example, the answer is square root 2. So in this case, the difference between this and this is going to be 1, right? Wait, no, in y, let's see. This is at... What is that? That's going to be... back right and front left. Okay, so we're going to take... Oh, Control P doesn't work. Command P. Oh, nice. Oh, yeah, lol. Okay, but what if we did this like this? Okay, I noticed a problem in the volume calculation and in just general how we store the cuboid data. Because when we have the 8 coordinates, those 8 coordinates actually define an orientation. So if you just take the maximum and minimum, I think that you of each axis, you get an incorrect box. I think you either get like an inscribed box. No, I think something's wrong. Gives you the yeah. I kind of hate that though. How do I calculate the volume? All right, so I feel like we could just do that. I don't really need the surface area. Okay, so maybe we can just do this. What are the cases when it's degenerate? Because yeah, wait, so in general math, if I have 8 points, how can I see that they might be degenerate? Degenerate? I don't know how to spell that. Meaning that it forms a plane or something, or a point, instead of a closed volumetric object. If the points are coplanar, they all lie on a single plane, meaning they don't form a 3D volumetric object like a cuboid. Geometry's so cool. What the hell? So okay, so let's do a basic example where let's do an example where okay, so A and B are the yeah, it's kind of interesting because we can compute the volume correctly in a way easier way. If we have A and B, then we just know it's going to be 0.4 times 0.2 times norm A minus B. So I mean, like the correct thing is if you have A and B, it's just going to be 0.4 times 0.2 times norm B minus A. I mean, this is the whole thing. Okay, so let's just rip off the band-aid and just delete that crap. So first off, this is dumb and is not correct. And then we're gonna I'm going to delete this. I'm going to copy in that other one. What? Oh, yeah. Okay, so this actually just needs to be... So all of these are going to be like that. Oh, crap. How do you make it a slice? Cool. So now we should be able to just comment out all of the ill-defined Okay, good. Line width is 4. Okay, okay. I can work with that. All right, I can work with that. That times 1.25 is, it's only about 0.8 grams over. So, okay, so, all right, so fix volume calculation by changing the struct of cuboid to just store 8 position coordinates. Okay, we're in striking distance of perfection. How will I know if he really loves me? I'll say a prayer with every heartbeat. Okay, cool. Very good stuff. Super happy about that, actually. We just need to... Now we need to start looking into how to take a union. Or what's the definition, I guess, of union? Wait. No. Oh my god. You are... Okay. It's dumb as rocks because it's made of rocks. I'm not made of rocks. Maybe I am made of rocks. What? Okay. No. No, I need precisely. I need to know. Okay. A cuboid defines a region in space. When I want the union, I now want precisely the points, a way to describe exactly those points in space that were contained by both of those. So the mathematical definition of union. I do not want a bounding box. Honestly, we could do some sort of weird sampling approach. Kind of seems fast. Wait. Is that... Okay, I haven't yet decided whether or not I think that's correct. Should we just try this Seagal thing? Now that we have... It'd be cool to learn Seagal. Seagal looks like it has some cool ass stuff in it, bro. I should probably make food. I need to leave. I don't even want to eat. That's the problem. But I'm going to be gone for all day. Ugh. Okay. I feel like that's a good stopping point. So the next time we're actually going to do the union and the boundary representation and all that. But for now, okay. I feel like that